Is it quicker to train an artificial neural network with more hidden nodes or more layers? Now, first understand what is hidden nodes. Hidden nodes are the individual artificial neurons or units within the hidden layer of a neural network. Each hidden node receives input from the previous layer or input layer, applies a weighted sum, and then passes the result through an activation function to produce an output. The output of a hidden node is then passed on to the next layer or output layer in the network. And what is a hidden layer? Hidden layer are collection of hidden nodes that reside between the input and output layers of a neural network. These layers are responsible for learning and extracting features from the input data through a series of nonlinear transformation. Now let's look at the situation where I'm adding more hidden nodes. So adding more hidden nodes within a single layer can increase the capacity of the model, enabling it to learn more complex and diverse representations of the data, as each hidden node can be thought of as a feature detector that learns to recognize specific patterns or features in the input data. It may converge faster in some cases as the optimization landscape is less prone to local minima and saddle points, which could slow down the training. And now on the other side, that if I add more hidden nodes continuously, what will happen? So as the number of hidden nodes increases, the number of parameters in the model also increases, which can lead to slower training times and an increased risk of overfitting. More hidden nodes may not necessarily improve the model's ability to learn hierarchical features, which is often crucial for tasks like image or speech recognition. Let's see an example. Imagine that you are working with a dataset of image containing various shapes. A simple artificial neural network with a single hidden layer and a few hidden nodes might only be able to recognize basic shapes like circles and squares. However, by increasing the number of hidden nodes in that layer, the network can potentially learn to recognize more complex and diverse shapes, such as stars, triangles, and polygons. This increase in model capacity can be beneficial when dealing with complex problems where a diverse set of features is needed to accurately represent the underlying relationships in the data. However, it's essential to strike a balance, as increasing the capacity too much can lead to overfitting, where the model learns to fit the noise in the training data rather than the true underlying patterns. Alright, so that was a discussion about adding more hidden nodes. And now let's look at the situation when I'm adding more hidden layers. So adding more hidden layers allows the model to learn hierarchical features, as each layer can learn increasingly abstract representations of the data. Deep networks can often achieve better performance with fewer overall parameters, as they can learn more excessive features through the composition of simple functions in each layer. But on the other hand, as the number of layers increases, the model becomes more prone to vanishing and exploding gradients, which can make training more challenging and time-consuming. The training time may increase due to the need for additional forward and backward passes through the network during gradient descent. So in conclusion, that is coming back to the question of whether you should add more hidden layers or add more hidden nodes. That depends on the specific problem and dataset you are working with. It's often beneficial to experiment with different architectures and choose the one that provides the best trade-off between training time and performance. In general, for tasks that requires the learning of hierarchical features, increasing the number of layers tends to be more effective, while for simpler problems, increasing the number of hidden nodes may just serve the purpose. And now I just want to cover another very related concept, that is, what is the purpose of having multiple neurons or multiple nodes in a single hidden layer? So the neural network is basically a tensor function, that is, it can be a scalar, vector, or matrices, and the network takes stuff in, for example, vector of some feature, and compoundly applies some operations like matrix multiplication or activation function and produces stuff out, for example, vector of probability distribution over some classes. The term neuron basically refers to a particular element of a tensor. Having one neuron in a layer means the layer would consist of a scalar value or equivalently vector of size 1, that is a matrix of size 1 by 1. Usually it's a good idea to have more dimensional tensor in a network. Example, you have network that takes an input of 10-dimensional vector. Apply matrix multiplication. The matrix multiplication is a learning parameter to get a vector of 64 dimension. Then apply element-wise activation function, for example it may be ReLU. Then apply, for example, softmax classification to get probability distribution over 7 different classes. The hidden layer have 64 neurons in this case, which means that the vector have a dimensionality of 64. If it had only one neuron, the dimensionality would be 1. The capacity or complexity of the network in that case would be much less. And note here that each neuron or node within a single hidden layer are learning something different. This is the whole purpose of having multiple nodes in a single layer. Although I would not say that they learn entirely different things, since they might have some correlation among themselves. But basically, each neuron will have its own view of the data and produces outputs according to it. It's like multiple people from different perspectives looking at the same thing, sharing their opinions, and these opinions are aggregated over and over again in subsequent layers in a neural network.